Hi everyone. As part of this problem, we have the input table as orders. This table has below columns order ID, that is the ID of the order date, that is the date on which the order was placed, order amount, that is the total expenditure done on that order. So every entry gives information about the orders. Note that on a single day, we can also have multiple orders being placed. So this is the input data set that we have. As part of the output, we need to identify that what is the no sale days gap. So for example, if we see here, after 23, there were 4 days, that is 24, 25, 26, 27. So 4 days in which no order was placed. So as part of the output, we need to specify the date after which how many days no sale days was present. So in this case, there are 4 days after 23rd January that no sale day happened. Similarly, if we see 28, so after 28, the next order was placed on 29. So there is no gap. So that's why 28 is not part of the output. Next is 29th. So after 29, there is a date 30 and 30 is not present here. That means there is no order placed on 30 and after that order is placed on 31. So there is a gap of 1 day. So even this will be part of the output. After 31, the next date is 1. So it will not be present in the output. And after 1, there is a gap of 2, 3 and 4. That is 3 days gap. And that's why it is present in the output. So this way we have to identify that how many no sale days gap are present between two order dates. So this is what we need to identify. So hope the problem is clear. We are going to use two approaches to solve this problem. So let's get started to solve this problem. So as part of the first approach, we are going to use recursive CTE. We are going to operate on this input table, that is orders. So let's get started. So how are we going to start is we are going to find the mean and max order dates in this column, that is order date. So let's get started with that. So let's find the mean of the order date. Let's call it as start date. And similarly, let's find the max of the order date and let's call it as end date. We are fetching the data from the orders table. So this way we will have the mean and max value of the order date. So let's run and see the output. So as we can see, we have obtained the first date, that is 23rd January, and the last date, that is 6th Feb. Now what we will do is we are going to generate all the days starting from the start date till the end date as a next step. So for that, we are going to use the recursive CTE. And whatever we have just generated, this will be our start condition. So this will be our base condition. So what we are going to do is we are going to do a union all here. And we will use this start date and add a day to it. Like we are going to increment one by one to this date. So we are going to use the dateAdd function and going to add a day and increment it by 1. So this way we are going to increment the start date column. So we are using the dateAdd function and saying that we want to increment the start date by days and increment it by 1 day. So say it is 28th of January. By incrementing it, it will go to 29th of January. So this way it will behave. In this case, it will start with 23rd January here. So it will increment by 1. So it will give the output as 24th of January as the next record. So this is the first thing. The end date column we will keep as it is. And this we are going to call from a CTE. So let's build a CTE here and let's call it CTE itself. And here we will have the recursive call for the CTE. And then we will specify the end condition wherein the start date is less than the end date. So this will run till the end date, start date is equal to end date. Till that point it will go. So let's get the records from this CTE and see the output. So if I scroll down here, as we can see, this column, that is start date, it will start from the minimum date, that is 23rd of January, and it will keep incrementing by one day. The end date we have hard coded as it is. Whatever is the max of order date, it will remain consistent across all the records, but the start date will keep incrementing by 1. So from 23rd January, it is keeping on incrementing by 1, and it will go till 6th of Feb. That is the end date. So we have got this. So we have got all the days starting from the minimum day till the maximum day. Now what we need to do is we need to identify which are the no sale days among these days. So for that, we are going to perform the left outer join. We will treat this CTE as our left side table, and we are going to join it with the orders table. So we are going to join based on the start date column, and in the order table, we will use the order date column and check whether on a particular date order is placed or not. So let's do that. Let's call this, let's give the alias as C here, and let's perform the left join on the orders table. So let's give the alias as O for this, for the orders table, and the join condition we will specify as start date from the CTE, which is the incremented date, and from the orders table, we will give the order date. So now what we will do is let's see all the data. Then it will be more clear. So if we see here, we have identified that for each of the days that we have, whether there is a entry present on the right side or not. And notice one thing, like for the days like 28th of January, there are multiple orders placed. So we have multiple entries, but we just want one entry to be present. So what we will do is we will trim the right table a little bit. That is what we will do is we will create another CTE. Let's call it as ordered CTE. And in this, we will get only the distinct order dates from the order table. And this we are going to use in the join condition. Why are we doing this? So that for a particular date, we only have one row corresponding to that. So let's run this and then it will be clear. Could not find CTE. Okay, so as we can see, we have obtained the output. Let's see the output. So now if we see for entries like 28th of January, wherein there are multiple orders, we will have only one entry created. So note that whenever we perform a join, if on the right side we have multiple rows that are matching, we will get multiple records in the output. But in this scenario, for every date, we just want to determine whether a corresponding entry is present or not. So we are not interested in multiple entries. That's why what we have done is in the right table, we have done kind of a filtering to keep only distinct order dates. And after that, we have taken a left join. Okay. So now for every date which we had incremented, right, from the minimum order date to the maximum date, we have done the left join and identified whether a order is there on that particular date or not. So if we are able to see the order date, it means there was at least one order and on that particular date. If it is null, that means there was no order placed on these days. And these are the dates which we are interested in. So as a next step, what we are going to do is we are going to operate on this data and kind of create groupings. Okay, so we are going to create this as a single group, like starting from the order date till where null is present, we are going to create a single group. For this, what we are going to do is we are going to use the count window function. So we are going to order it based on the order date and count this order date. So let's write the query and then it will be more clear. So what we will do is let's add whatever output we just got as part of a CTE, and let's call it as details CTE. Okay, so now we will operate on this data which we had. So what we are going to do is we are going to add a window function of count. Okay, so we can do it at this step itself. So what we can do is we can count the order date that is coming from the orders table o dot order date. And when we are specifying the window, we have to specify it as order by the start date that is coming from the CTE. And let's call this as count group. So let's run and then it will be more clear of what we are trying to achieve here. Okay, so we have executed the query. Let's see the output. Okay, so if we see here, what we have done is we are counting the order date. Okay, so here there is a value present, so it will give as 1. And then since we are doing a window function, it will keep counting in the increasing order of the start date. So when it will count this, whenever we specify count of any column, nulls are not considered. So in the increasing of the count, it will give 1 only here. And similarly here also it is null, so it will give 1. Here also it will be 1. Now here as the value is present, count will be incremented by 2. Similarly here count will be incremented by 3. And whenever null is present, count will remain as it is. Count value will not be incremented. Why it will be not incremented is because inside the count, we have specified the column of order date and we are ordering it based on the start date. So counting will happen in the order of the start date and counting of order date will happen. So wherever null is present, count will not increase. It will remain as per the previous row, but whenever value is found, it will increment by 1. So if we reach till this step, we are almost near to the solution. As we see, with this grouping, we have identified different groups, and whichever group we have more than one entries, those are the ones which we are interested, because those are the ones where the gaps will be present. If there is only single entry for a group, then that means that it will have only, like it will have orders, it will not have any gaps after that. Okay, so we will focus on this count group and order date function. These two will be our main priorities here going forward. So what we are going to do is, for a particular group, we are going to take the max of the order date. So max of this will be 1st of Feb 2024, because if we are doing max of all the nulls and a value, it will always give that particular value. So if we do max of this, it will always give the value, because we know that for a group, there will be only one date that will be present. So if we go to any group, there will be only one date present. And if we take max of this, it will be this particular date. And post that, we have to count the number of entries and subtract it by 1 to get the gaps. So here there are 2 entries for this group. If we subtract 1, we will get 1 as the output, which is the requirement. Similarly, in this group, we have total 4 entries. So if we subtract it by 1, we will get 3 entries, which is the number of gaps present after 1st of Feb. So this way we will solve the problem. So we simply have to do what? We simply have to take the, so let's see the data as well, and then accordingly let's write the query. So we simply have to take the max of the order date. Max of the order date, and call it as say order date itself. And after that, next is we have to count the number of entries and subtract it by 1. So for example, if it is the 5th group, there are 4 entries. So if we subtract 1 to remove this valid entry, we will get the number of gaps days. And let's call it this as diff. So let's run and see the output. So here we have to add the grouping as well, that is group by count group, so that for every group we get different values. So like we see here, now we have got for every group what is the maximum date and what is the total difference of days after that particular date, like what is the no sale days gap. Now we only need to keep those entries where the difference is like having a proper value. So in this case, we need to add a filter clause here, or here we can add the having clause of count greater than 1, because we are subtracting it by 1 here. So this is the final output that we have got. Okay, so we have identified what is the total gap after a particular order where no sale was done. So after 23rd of January, there are 4 days, that is 24, 25, 26 and 27, where no sale was done. So likewise, for each day, we have identified the output. Okay, so we are done with the first approach. Let's move on to the second approach. And second approach will be a little simpler approach as compared to what we have just done. So in the second approach, we are going to explore the lead function to solve this problem. So let's use this approach and solve the problem. Okay, so we are going to work on this orders data again. So what we will do is, first, as a first step, we will keep only the distinct order day, so that if there are multiple orders on a particular day, we don't have duplicate entries. So to eliminate the duplicate entries, we will just add the distinct order days. So by using the distinct keyword, or we can also do select order date and then group by on the order date. That way also it is fine. The idea here is get the unique days from this orders table. So let's call this as, let's add it as part of a CTE and call it as order CTE. So now what we will do is, we are going to find the next value for every row. Okay. So if we have to find the next value, we have to use the lead function. So that is what we are going to do. So along with the order date, we are going to find the lead function. We are going to use the lead function to find the order date, and we are going to order it based on the order date to find the next row and call it as, say, next order date. For every order, we will identify what is the next order date when the next order was placed. So let's run and see the output. So here, as we can see, for every order date, we have identified what is the next order date. Okay, so the very next order date we have identified by writing the lead function. Next thing what we have to do is, we just need to take the date difference between these 2 days. So if we take the date difference, we will somehow reach near to the solution. Like we will identify the gaps of days that are present. So what we will do is, we will use the DATEDIFF function to calculate the date difference. And we want the date difference in terms of days. So we will specify that as a first parameter, we will give the order date, and as a second parameter, we will specify the next order date. And this will be, let's call it as difference. So let's run and see the output. So as we can see, we have identified the date difference between these 2 days. But while calculating the date difference, it is giving 1 day extra. Okay, because it is including the date, including the 28th Jan date as well here while calculating the difference. So since we have to find only the gap, we will subtract 1 here, and let's run and see the output. So now we have got the right difference. Okay, we have got the data as required, but we need to remove certain records where there are no differences present. So we need to remove all such entries. So what we will do is, we will add this as part of a CTE, and let's call it as details CTE. And on this CTE, we simply have to just add the filter to remove the records that are no longer needed. So we will keep only those entries where the difference is greater than 0. Okay, so let's run and see the output. So now we have got the required output. We have got the difference between the 2 dates and then calculated the gaps between them, and which has given the right output. As a last step, we will keep only those columns which are required, that is order date and diff. So let's run and see the output. So this way we have solved the problem. We have identified the gaps that are present as to between two order date, which are the number of days where no sales was done. Okay, so we have solved it using two approaches. So let's do a quick summary of how we have solved the problem using approach 1 and approach 2. So first we will walk through the first approach. So in the first approach, what we did is, first of all, we used the recursive CTE. We started with the base condition wherein we have identified what is the minimum order day and maximum order date between all the orders that was placed. And then this is our base condition. And we have built a recursive CTE here wherein we are going to increment one day starting from the start date till we reach the end date. So we are going to keep incrementing by one day. So using this recursive CTE, we will build a list of days starting from the minimum start date till the end date. So we will have all the dates that for which the order was done from the minimum date till the last date. After that, as a next step, we have taken the distinct values of order date. So this will have the list of dates on which the order was placed. If there are multiple orders placed on a particular date, only one entry will be present here. As a next step, we are taking our CTE, the first CTE, which has all the dates as the left side table. And on the right side, we are going to take this distinct order table. So we are going to perform the left join and we are going to match it on the start date and the order date column from the orders table. So if the match is found, it means that there is an order that was placed on that particular date. And if the match is not found, on the order date side, null will be present. So as a next step, we are using the count window function. We are counting it based on the order date in this order by start date. So start date will always have a value. So in this ordering, we are doing the count. So for the days where the order date is present, count will be incremented. And if it is having null, count will retain the value same as present in the previous row. As this is a window function, it will go through row by row. So this way we have created a count group. Once we have the count group, it is very simple. We have to group based on this count group and get the maximum order date to fetch the date on which the last order was placed. And after that, we take the whole count entries and decrement it by 1 to identify the gaps that are present. We have added a having clause as we want to keep only those entries where the total count is greater than 1. So that along with that particular date, there are gaps present. So that we have identified using this having clause. So this way we keep only the relevant records where gaps are present. So this was the first approach that we used to solve the problem. Let's walk through the second approach. So in the second approach, the major role is of the lead function. So what we have done here is, first of all, from the orders table, we have kept only the distinct order date so that on a particular order date, only one entry is present if our order is placed. As a next step, we have identified what is the very next order date where the next order was placed. So since we have ordered it by the order date, we will be able to identify using the lead function what is the next order date. So once we have that, from this order date to the next order date, we will take the days difference to identify what are the gaps that are present. We will subtract it by 1 to get the exact gaps. So once we have done this, we will keep only those entries where the gap or where the entries are more than 0. Okay, so that we identify that we have got the gaps records present here. Only the gaps record are picked in the output. So this way we have solved the problem using the two approaches. So please go through the video. If you found it useful, please like it. If you have not yet subscribed the channel,
comment,
please
and
subscribe
subscribe.
and please provide your feedback in the comments. Thank you.